start streaming. Don't say it. Okay, we are live. So, we're going to talk about polyhedrons today. Now, before we get real in depth into anything, I want to talk about this prefix of this word right here. Okay, where have you seen this prefix before? Okay, so polygon, which means what? Many sides, right? Where else have you seen poly before? Poly, I will not spell this right, but I'm going to try, okay? Polydeism means, I think it's many gods. Like you believe in many gods, right? Polydeism. Can you think of anything else? Have you ever heard, now this one you don't say poly, but have you ever heard of this? Polygamy? You know what polygamy is? No. Many wives. Polygamists marry more than one person.
Oh, that one dude did that, didn't he?
Yeah. Huh? Well, yes, he had two husbands. They weren't wives. They were.
Wait, what? No, the one dude did that with Wakathon. That one dude.
The bald guy? Maybe? I don't remember. But this is actually illegal. You can't have multiple wives. But what people will do, there is a section of a specific religion that believes that you're supposed to marry many wives. Like that's what they believe. And what they will do is legally marry one person and then spiritually marry the other people. They're not legally married to more than one person. So they have multiple wives at one time. It's nuts. And yet weirdly fascinating at the same time. I mean, just that the way they... You just have to... Have y'all ever seen Sister Wives? Y'all never seen that? It's just weird. It's crazy. Like, I can't imagine. No. Thanks. Mackenzie Pierce's grandma got that for me.
It was this dude.
I don't remember that guy.
Because remember all the girls, they like he had big hats and stuff? Yeah.
Okay. Okay. The whole point behind all of this is that the prefix poly means what? Many. So if we're looking at this word polyhedron, and we're looking at this shape right here, what's your best bet on what a polyhedron is? Those are good guesses. I love that way you're using your context clues there. So it's not sides because polygon is many sides, right? It's faces. Many faces. So let's talk about what a face is. So polyhedron is many faces. So what's a face? And I don't mean this. It's the flat side, right? The flat side. Polyhedrons have to have flat sides. So if it's a curve, it doesn't count. It's not a polyhedron, okay? Now when you're talking polyhedron, y'all see all these guys up here, right? Oh! We got these. We got this. This is a polyhedron. Here's a polyhedron. Here's a polyhedron. Here's a polyhedron. I think some of these are. Here's a polyhedron. Right? Okay. You'll see all these different shapes I'm pulling out of here, right? These are all polyhedrons. And there's more. I'm just trying to pull up the ones that are just nets. There's a polyhedron. There's a polyhedron. Okay, so you see all these polyhedrons, right? They all have flat sides, right?
Yeah.
Now, then we have this guy. Why do these have strings in them?
Probably to hang on. Is that what evaporate?
No, it's something to. What is that? I've never seen one like this.
What's it? It goes from
Like, I think it's to show that this distance here is different than this distance here. I think that's what it's for. Anyway, okay, y'all see this shape though, right?
Yes.
Not a polyhedron.
Yeah.
Why is this not a polyhedron?
That's curved side.
It has curved sides. What about this guy?
No.
Nope, not a polyhedron. It's got curved sides, right? So these guys are all polyhedrons. What about this one right here?
No. That's a circle. That's a sphere.
That's a sphere. So what's this one called?
Cone.
Cone, like an ice cream cone, right? Cone. Sphere. What this one?
Cylinder.
Cylinder. Okay. And we're going to talk about spheres and cones and cylinders, but our main focus today is going to be on polyhedrons. You know what? I've been doing all of that and not showing none of that. Oh, yeah, I have. Never mind. Okay. So our focus today is going to be on polyhedrons, which have flat surfaces. All right. So here we have these that have these flat surfaces. We have this guy. Okay. And this guy, and this guy right here, and this guy right here. So I've got all of these. What do these all have in common? Can y'all see them? They've got triangles, so they all have triangles on the sides, right? What does them having triangles make happen? We're coming back in a minute. We're coming back to that in a minute, okay? But having a triangle here, 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 and here does what to the shape? Like it does a thing.
Makes it all.
Comes to a point.
Ooh.
If they weren't triangular shapes, it wouldn't come to a point. But it comes to a point because these triangles, to fit together, it's wider at the bottom than it is at the top, right? Now, so every one of these triangular ones all come to a point. Y'all see that? They have a special name. If it's triangular and it comes to a point, it's called a pyramid. Okay? Now, every one of these pyramids, these are the same. Every one of these pyramids are different though. So this is a pyramid, this is a pyramid, this is a pyramid, but they're three different kinds of pyramids. And that's based, Lance, on the base. So they all have different bases. What is the base of this guy? A triangle. What's the base of this guy? Hexagon. This guy. It looks like a square. It probably is a square. It may be just a rectangle, but it looks like it's a square. So this guy, triangular base, is called a triangular prism because it has a triangular base. I'm sorry, I said prism. Pyramid. Triangular pyramid. This guy, because its base is a hexagon, is called a hexagonal pyramid. Okay? This guy, because his base is a rectangle, is called a rectangular pyramid. Y'all see how that works? So the base and then the shape, okay? Then we have these. Let me pull these over. All right? So, y'all can see these, right? What do these guys have in common? They all have quadrilaterals as sides, right? Which means they don't come to a point. They go up straight because the quadrilaterals are the same size at the bottom as they are at the top, right? They're even more specifically than quadrilaterals. They're actually just rectangles. They're not even just quadrilaterals. They are rectangles. So their sides are all rectangles. So what do you notice about their tops and their bottoms? Let me rephrase my question, because what you answered is accurate, but wasn't what I was trying to ask, okay? What do you notice about the top and bottom of this shape? It does have a bottom and top that is a hexagon. What about those two hexagons? They're even. They're the same, aren't they? So, what about this one? Bottom and top. Square. Are they the same? This one. Same? This one. Yep. This one. So these shapes, where they have rectangular sides and the base at top and bottom are the same, are called prisms. And prisms, also like pyramids, have two parts of their name, their base plus prism. So this would be called a triangular prism. This will be called a rectangular prism. This would be called a hexagonal prism, right? And this would be called a... Yeah, these are the same. Just one's different. They're just different sizes. But they're both rectangular prisms. Now, this one here is special. This is a cube. And a cube is a rectangular prism that has all the same side faces. All the faces are the same side. Now, the faces are every one of these flat spots. Those are faces. You may know what this is called? Those are called edges. So the edges, if you were walking on this shape, if you were a tiny human, if you were shrunk, if you were in Honey, I Shrunk the Kids, and you were tiny and you were walking on this, if you were walking and you would fall off, that's an edge. Okay? What is it called where they come to a point? Vertex. If you're talking plural, it's vertices. So if you see the word vertices, that just means plural of vertex. Vertices. Not vertexes. I actually like the sound of vertexes, but it's not accurate. Okay. So we get the concept of the difference between pyramids and prisms, right? I think I broke that one. No. That was not mine. These, I think. These are mine. No, that's wrong. No. See what happened? Let me explain.
Whoa.
What happened was, when we moved from the old building, stuff got mixed up. And we've never got it all sorted out. Huh? Okay, now. And it don't matter. You can store them. I can go borrow. Okay, so if I ask you to name your base or your bases, you have two bases. You have the one that's on the bottom and the one that's on the top. If it is a prism. If it's a pyramid, you only have one base, right? If you're naming your bases, then you're naming that shape, and then you use the points that create that shape just in order that they are on the thing. So, like if we're if we're naming this base right here, we would call this base rectangle VWTU, right? And if we're naming this base on the top, we would call it rectangle YXSR, right? And that's all you do to name the base. You name the letters in the order they are on the shape. If you get out of order on the shape, you're not naming the base accurately anymore. Okay? if we're asked to name the edges. So what are those edges?
Like the line.
It's everywhere there's a line. Everywhere there's a line is an edge. Now, what geometric shape are those edges? What geometric thing are each edge? Let's do this. Name an edge. Okay. I knew it.
What?
But what is it? Is it a line?
Segment.
It's a segment. So we would say segment SX, right? What other edges do we have? Segment RS. What else? Segment YX. What else? Segment UT. We missed one. Y'all realize we missed one, right?
Segment VW.
How about RY, since we missed that one? VW. VU. TU. No, we got UT already. VY. BY. XW. ST. RU. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're missing one. We're missing TW. Okay, so that's all the edges. And then the vertices, if we were naming the vertices, we would just name each point where they come to a point, right? So we would say X, Y, R, S, V, W, T, U. Those are all the vertices. Y'all see how that works? Okay. If you look at number 2, is that a polyhedron? Mm-hmm. How do you know it's a polyhedron? It has flat faces, right? That makes it a polyhedron. What type of polyhedron is it? It is a pyramid. Let's name it. So what specific pyramid? Pentagonal pyramid. It's a pentagonal pyramid. How do we know that? Our base has 5 sides. So that means the base is a pentagon. So we would call it a pentagonal pyramid. If we were going to name that base, we would say pentagon A, B, C, D, E. Now we could start with any letter. We just have to go in order that they are on the shape. And traditionally when we name things, we put it alphabetically if we can, right? It doesn't always can't always go alphabetically, but if we can, we put it that way. How many bases are on this one? One base. How many faces? There are 6 because the base is called a face. The base is a face. We just call it a base also. What about number 3?
No.
Yeah, it is not a polyhedron. It is a solid. It's a solid. It's just not a polyhedron. Okay? So, it's a 3-dimensional shape, just not a polyhedron. Polyhedron has to have flat edges, and it has curved edges. Right? All right. Let's talk about number 5. We're going to skip number 4 and come back to it later. Let's talk about number 5. So on number 5, they're asking you to find the surface area of this shape. Now, what does surface area mean? Does anybody know? So, surface area, everybody tries to make it real complicated. It's so simple.
The area of the top.
It's the area of the surface.
Yeah, definitely.
So, if you're looking at a cylinder, what would you consider the surface of the cylinder? All the way around. Is that it, though? And then on the top and on the bottom. So the surface is anything that you could touch, right? We're not talking about the area inside. We're talking about the area that you could touch. Surface area. That's what surface area means. The area of the surface. There is a complex formula to find the area of a cylinder. But if we use our brains for 2 seconds, we can figure out what the area of this cylinder is without memorizing a complex formula. We know how to find the area of a circle because we worked on it for days. How do you find the area of a circle?
Pi times R square root.
Pi times R squared,
Yeah.
right? How many of those circles do we have? We have 2 of them. So we're going to take the area of this circle that we find, and then we're going to multiply times 2 because there's 2 of them. So we're going to do pi times 3 squared, but then we're going to multiply that times 2 because we have 2 of them. Now, just for easiness sake today, we're going to leave pi in there. We're not going to multiply it out. So we're going to get 3 squared is, what's 3 squared? 9. What's 9 times 2? 18, right? So it's going to give me 18 pi. Now, I could multiply that out, but I don't need to. I'm going to leave it as 18 pi. Okay? 18 pi centimeters squared. Now, before I pull this net out and show you, I want you to visualize what this shape right here looks like if I pull it out and lay it down. If I pull this out and I lay it out, because that's what a net is. That's why I have this. What it,
Rectangle.
you think it'd be a rectangle?
No, it'll be like 2 circles.
Like this. I'm thinking my baby.
You think it's what it'll look like?
Wait, hold on.
That's something you probably.
Wait, how does it
Yeah, that makes sense. This
No,
one-
it'll be like a circle up here, circle right here. And then this one.
No, because these two they fold around. It's like it's
Here,
like
let
no.
me show you.
Use your own pencil. It's like a big hug.
Get your own
and then
pencil.
the circles are like on it.
Okay. So, this one is not drawn exactly. I wish they actually hadn't done it like this. But this is not drawn exactly the way that Williams is.
William, like this.
But Williams' concept is correct.
I see. It's on the edge. I'm sorry.
I know.
William.
I know. And I agree. That's what I said. I wish they hadn't done it exactly like this. Pretty much anything else would have been better. Yes. Yes. And if we detach this circle here and connected it on here, it would still work, right?
Oh, we have a minute left.
But the reason they did it like this because it's easier for them to make. Okay? Now, the question is, how do I find the area of this?
Find the area of the 2 circles and find the area of the big rectangle.
Okay, so we got to find the area of the big rectangle. Now, if you're, we'll talk about this tomorrow. Y'all have a great day.
Oh, good luck doing that every class. Yes, man.
I know.
You see, do it with a different shape.
Well, except for that's the way a cylinder works.
Wait, no, you had geometry 6th period too.
Mm-hmm.
Do a 6th period. Isn't that when you have strings?
Mm-hmm.
Yes, you do.
Yeah, do that period.